Hi and welcome to chandu.org. In this video lesson, let us understand how you can build a break-even analysis model using various features of Excel. For this purpose, we're going to take up an imaginary problem called as Sarah's copier shop. Okay, let's take a look at the problem. This is actually a problem that one of my readers posted on a recent blog post. Recently, I have asked our readers on chandu.org, tell me about an analysis problem that you couldn't solve with Excel, and there were quite a few comments and emails that I got, and one of the interesting ones is this one. Of course, there are quite a few interesting ones, but for this particular video, I want to take up this one because it has a lot of depth. Essentially, the problem is, imagine you want to open up a copy shop, a place where people can go to get some copies or prints. Now there will be some costs and there will be some benefits associated with it. The cost side would have things like your leasing costs for copier or the outright purchase cost, as well as the variable cost involved with printing the copies. You have to pay for the paper and electricity and other things, and then there will also be costs like your rent, etc. On the benefit side, on the revenue side, you would be making money every time a customer takes a copy from you. They'll pay you 10 cents or 15 cents or whatever. Okay, so this problem deals with that. Essentially, the description is here. The key things to keep in mind are $5,000 lease to lease a copier for an year, and then operating costs are 2 cents per copy per paper. There are also other variable expenses, which would be about $300 per month for rent and other expenditure. And you are expecting that the customers will pay 11 cents per copy when they take a copy from your shop. Now you plan to keep this store open year round, so 365 days, and you can make up to 100,000 copies per year. That's the maximum capacity for the each copier. Okay, so if you are anticipating more demand, then you would have to go and bring in additional copiers. Okay, so you'll have to pay extra lease for that. Now you are assuming that there are 4 possible values for the demand, which would be 500, 1000, 1500 or 2000 copies per day. And the task that the person was trying to do is develop a spreadsheet model to address the following question: provide a mathematical model formulation to evaluate the total profit for a given daily demand and given number of copiers leased. Okay, so for an input of total demand and the number of copiers, you want to find out what is the total profit that we can make. Likewise, to determine the optimal number of copiers to lease by looking at various combinations of number of copiers and total demand. Okay, so that's that. Now let's go ahead and understand this a little more. The key facts are your copier lease, which is about $5,000 per year, your operating costs of 2 cents per copy, rent is $300 per month, and revenue is 11 cents per copy, and the capacity is 100,000 copies per year per copier, and you are anticipating demand to be between 500 and 2000 copies per day. Now whenever you have something like this, the first thing that I would recommend is, instead of jumping right into Excel and trying to build this thing, write down the key equations. Okay, in a business scenario like this, you usually have 2 sets of equations. One is on the cost side, the other is on the benefit side. So we will go and look at them. We have the expenditure side of equations, wherein we have total cost defined as fixed plus variable cost. The fixed cost is equal to copier lease times number of copiers plus rent times 12. Now number of copiers is in a different colors because we don't know how many copiers there will be. That's a variable for us. Likewise, variable cost is equal to per copy cost multiplied by total copies. We can also derive the number of copiers as a formula that says total copies divided by 100,000 and then rounding up that number. So if you have, let us say, 180,000 copies, then you would need 2 copiers, because each copier can provide up to 100,000 copies. On the revenue side, the equation is very simple. You have per copy revenue multiplied by total copies. Okay, so now that you understand the equations, the mathematical part behind the model, the process of constructing this model is very simple. We will go into Excel to build this. So create a blank workbook and list down your input variables in a clearly defined area. I'll just collapse the ribbon so we have more space there. So we'll call this as inputs, but usually whenever you are building a model like this, you may want to put all the inputs in one worksheet, and the model can go into another worksheet that depends on the input worksheet. But for the sake of explanation and seeing everything in one page, I'm going to keep all the inputs and calculation in the same tab. So there are two kinds of inputs. You have your costs and the revenue inputs. We'll just type them here. Cost inputs are lease is $5,000 per year, rent is $300 per month. Okay, likewise you have your operating cost is 0.02 per copy. Okay, notice these things because these are very important. Whenever you are building a model, you usually have an item along with a qualifier or a quantifier. This will tell us how to use that number in what context. So if you're calculating yearly costs, you need to calculate total rent for the entire year by multiplying this with 12, like that. So these are the key costs that we have here. We will also have another variable in the cost side, which is called as a number of copiers. Okay, we don't know how many this is. Let's just say this is 1. Ideally what you would do is, when you're building a model like this, you can list everything like this, but because this is a dependent variable, you can also put this in a separate section of the model so that it's easy to control or change this during the course of your model development. Okay, for now we will leave it there and we will come back and see what to do with that. On the revenue side, we have revenue is 0.11 per copy. Okay, now we will also have another variable which is total copies or demand. Demand would be 500. Of course it can vary from 500 to 2000. We don't know what the demand is going to be, so this is per day. Right, now here we have these variables per year, per month, per copy, per day, like that. They are scattered all over the place, so it may be a good idea to unify these all things on a per year basis. So this is simply 5,000, whereas this is multiplied by 12, and that is going to be multiplied by 365. Okay, even at the lowest level of demand, 500 per day, you could see that we will end up having 182,000 copies. Now this is clearly more than the capacity of the copier, which we could note here as capacity is 100,000 per copier / year. Okay, so in this case what we need is, we don't need 1 copier, we actually need 2 copiers for that demand level. Okay, so we will link up this formula as that divided by this. Now when you do a simple division, you're going to get an answer saying we need 1.825 copiers, which is ridiculous. We need a round number of copiers, so we're going to simply say do a roundup of that to forgot to add 0, to do a roundup and add 0 decimal points. That'll give you the answer. Okay, we are only using relative references so far, but it's a good practice whenever you're building a model to either use absolute references or use names. Okay, now naming everything is going to complicate things here, because that will just delay the process for us to build the model. But we will first build the model and then come back and see how to add names. So I'm going to put some different color on the variable cells. Although these appear to be, the number of copiers is appearing to be dependent on the demand, the reality of running a business is that at the start of the year you don't really know what the demand is going to look like. You can only go by an estimate. So that's what Sarah is also doing, right? She is saying, I'm estimating the demand to be anywhere between 500 and 2000, but she doesn't really know what the demand will look like. So she would have to make a guess and buy 2 copiers. But what happens if the demand jumps to 1000? In which case she actually needs 4 copiers, not 2, but she's stuck with 2 because that's the lease that she has signed. So in real life, these are not exactly dependent on each other. They are independent variables that you control, not really control, but at least you have to model for them. Why I'm not saying control is because even the demand aspect is not in your control. It actually is something that is outside the business domain, and you never really know what kind of demand would be there. Sometimes there could be 5000 copies demand on a day. On some other days you may not get even a single copy. Okay, now let's go back and set this to 500, and so those are our inputs. We will do the calculation of costs. Costs will have 2 components, which is our fixed cost, which happens to be per year lease multiplied by number of copiers. Okay, I wrote fixed, but it's probably better to write lease, rent, and operating, like that. And the rent is going to be that one, and our operating costs are going to be per copy costs multiplied by total copies. Okay, so there is your total cost. So the total cost is sum of these 3 components, which will be a simple sum formula. Okay, revenue is copies is the head here, and we will simply say per copy revenue multiplied by total copies. Okay, so we'll get that. Now you could see that in so many places in our model we are accessing the this number 182,000, and this is always F11. But if referencing to F11 is going to be tricky, what I would recommend is you can give this a name. We will call this as demand. Okay, and simply use multiplied by demand. Okay, now this is fine, but if you want to change all these formulas to include the reference to demand, then you would have to go and edit every now and then. What you can also do is you can select the cells where that has been used, all the cells, by holding control and selecting all the cells. I'm going to your formulas and apply names. Okay, so it will be in the define name section, and select the name that you want to apply and click OK, and the names will be applied in the formulas so that you can take care of the names that you have created after developing the model. Okay, so we will make $20,000 and we have $17,000 as our costs. I'm going to select all of these and let's apply dollar formatting there, and profit is nothing but your revenue minus expenditure. So we are going to make $2,800 profit by renting 2 copiers and assuming the demand is going to be 500. Now the problem is, of course the mathematical model is good, and if you change anything, you change 1000, then you will know the profit. If you change to 1500, you'll know the profit, and if you change to 2000, you will know the profit. and because this is linked to that, automatically the number of copiers will also change. So far so good. And that answers the first part of the question, which is provide a mathematical model formulation to evaluate total profit for a given daily demand and given number of copiers leased. Okay, now this is partially answering the question, because here we are taking input as daily demand and we are determining how many copiers are needed. Okay, so this is not a given, this is actually determined based on the daily demand that we are inputting. Now what if you wanted to separate these two? What if you want to break the relationship here and make that as an input parameter? In which case what happens is, let us say I don't have a formula here, I'm simply going to say I only have 2 copiers. Okay, in which case my total demand of $2,000 per 2,000 copies per day means I would be printing 730,000 copies over time. But because I only have 2 copies, my total capacity is simply that times that. Okay, so I can only print out 200,000 copies. I can't print 730,000 because I don't have that many copiers around. So my operating expenditure won't be equal to demand, but it would be lesser of the capacity or the total demand. So what we could do in this case is we can modify this formula to be minimum of total demand or total capacity. Okay, so this way when you have 2,000 capacity, you will only make $4,400 profit, but if you bring in one more copier, you will make 8,400. Like this, if you bring in 8 copiers, your profit can also go up. So now what we have done is we have made these two as variables, the D7 and D11 as variables. Okay, so that's the mathematical model for that. Now let's go ahead and build a model that will give us the optimum mix of number of copiers and demand. Okay, and this is where we will say optimum mix of we will list the number of copiers that we can have. So we can say we can go from 1 to all the way up to 8 copiers, and the demand can be 500, 1000, 1500, 2000. And what we want is we want to calculate the profit values for all these combinations. Now we could go and write these big complex formulas for each and every combination, but that's not good. We could use Excel to calculate all of these. Okay, we can just tell Excel, hey Excel, please excuse me, please calculate the profit value. That's our orange cell, and please calculate the orange cell value D22 for each of those combinations. Okay, we will simply put this equal to here, bring the profit there. Okay, so the profit value is also shown on the top, and we can select this entire range, and we will use a feature called data tables. This is available in your data ribbon what if analysis data table, and we will say what is the row input and what is the column input. So row input would be your demand, the number there, and that's that one, and the column input would be your number of copiers. And when you click OK, Excel will calculate the values for all of these things. Okay, so you could see immediately that if you have 8 copiers and your demand is only going to be 500, then you will make a loss of $27,000, because you will end up paying lots of lease but not making enough revenue. Whereas on the other hand, if you have $2,000 copies demand and you bring in 7 copiers, you can make a profit of 24,000. Okay, so this is really telling you where the optimum happens. And what you could do is, once you have built the data model with the data tables like this, you can select one of the rows, okay, and go to conditional formatting, top, and then select the top 10 items, and then simply say show me the top one item, or maybe top two items. um, and you can see for 500 demand what is the top two item. Now you can apply the same rule to other cells, but instead of applying this manually, you can select the first range, go to home ribbon and click on the format painter, and click on that like that. This way you can instantly see the top two profit values for each combination. If you want, you can restrict this rule to top one, that way you will only see the best profit. And you can see the anomalies here. For example, if I'm anticipating the demand to be around 1500 copies per day, I should probably stick to 5 copiers instead of 6, because an additional copier would increase my lease amount by $5,000, but the revenue is not enough to justify that. Same happens for 7 and 8. With 7 copiers I'm going to make $24,000 profit, whereas with 8 copiers I'm going to make $22,000 profit. So that is how you can build a model, use data tables to automate the calculations for various permutations, and then use a bit of conditional formatting to see which combination yields the best results for you, and then pick the decision based on that. Now if you're thinking, oh, this is all good, but how do I make it more realistic? That's because in real life you're not going to get 2000 copies per day consistently for all the 365 days. So in this case, what you can also do is, let me save this first. What you can also do is, instead of having a fixed number for demand like 2000 or 300 or 700 copies per day, you can bring in two variables: average demand and standard deviation for the demand. So you can say on average we are expecting the demand to be 500, but there is a standard deviation of around 25 copies per day. So based on this, you can build a distribution of the demand over a period of year or something like that. For example, if you expect the demand to follow a normally distributed random pattern, you can generate normally distributed variable from these two numbers, and then use them in your model to simulate what your profit is going to look like for a demand and standard deviation combination. Ideally I would do something like that, because that way we can get more semi-realistic figures. Why I'm saying semi-realistic, why I'm not saying realistic? That's because there is really no way we can predict the demand over for next 1 year, no matter how much computing power you use and how much you define the problem. So demand or any forecast like that depends a lot on how well you know the market, what the competition is going to do, and a lot of unknown variables that can't be modeled into your Excel thing. So the best that you could do is, at least a step up from fixed demand per day, is to bring in a little bit of standard deviation, so there is a bit of variance, and that can help you understand overall uh, uh, demand over 1 year, and then build the model according to that. But also, when you start a business, you are taking some risk, and sometimes you may take too much risk, sometimes you may take just enough risk to justify the return on investment. So there you go. This is how you will build a model to help Sarah build her copy shop. I hope you find this enjoyable. Please visit chandu.org to grab a workbook of this model and play with that to learn a little more. And if you find this particular video interesting, subscribe to our YouTube channel for more awesome content and give us a thumbs up. Thank you so much. Talk to you soon. Bye bye.